In 1928, a physicist wrote down an equation. He wasn't trying to predict a new universe. He wasn't searching for a hidden particle. He was trying to fix a mathematical inconsistency. But when the equation was finished, it contained something impossible. A particle identical to the electron, but positively charged. No one had seen it. No one had imagined it. The equation demanded it anyway. 4 years later, it was found in a cloud chamber. The math was right before reality caught up. This has happened more than once. James Clerk Maxwell wrote equations describing electricity and magnetism. When he solved them, the math produced waves no one had ever observed. Not light, not radio, not anything known, but the equations insisted they must exist. Years later, radio waves were detected. Again, mathematics arrived first. This is the uncomfortable pattern. We invent symbols. We manipulate abstractions. We follow internal logical rules. And somehow, the universe obeys them. Not metaphorically, not poetically, precisely. Why should equations written by biological organisms on a small planet describe the behavior of stars, fields, particles, and space-time itself? Why does the universe behave as if it is structured mathematically at its core? Some call this the language of God. Others call it coincidence. Tonight, we are not choosing sides. We are asking a harder question. Is mathematics something we invented to describe reality? Or is it something reality was already written in, long before we arrived to read it? Mathematics does not behave like a tool. It behaves like a key. A tool helps you describe what you already see. A key opens something that was locked before you arrived. Physics is filled with examples where mathematics did not merely organize observations. It predicted structures no one knew existed. Paul Dirac wasn't searching for antimatter. He was trying to reconcile quantum mechanics with special relativity. He adjusted the mathematics until the equation stopped contradicting itself. But when the equation stabilized, it contained an extra solution. A mirror version of the electron. Same mass, opposite charge. The math didn't allow it to disappear, so physicists went looking. And they found it. Antimatter was not guessed. It was demanded. The same thing happened with Maxwell. His equations unified electricity and magnetism into a single framework. When he solved them fully, they produced wave solutions. These waves traveled at a specific speed, the known speed of light. The conclusion was unavoidable. Light itself was an electromagnetic wave. No experiment suggested that beforehand. The mathematics forced the realization. This is the pattern that disturbed Eugene Wigner so deeply that he called it the unreasonable effectiveness of mathematics. Why should abstract symbols, constructed in the human mind, map so precisely onto physical law? Why do equations not merely describe reality, but anticipate it? If mathematics were just a language we invented, we would expect it to fit approximately, loosely, with correction factors, with patches. Instead, it locks onto the structure of the universe with surgical precision. When equations predict something new, we don't celebrate coincidence. We build detectors, and more often than not, the universe complies. This is not beauty, it is authority. The deeper physics goes, the less it looks like we are inventing models, and the more it looks like we are uncovering something that was already there. So the question sharpens. Are we discovering a structure that exists independently of us? Or are we mistaking the success of our abstractions for something metaphysical? Because if mathematics keeps predicting reality before we observe it, then either the universe is written in math, or we have not yet understood what mathematics really is. At the deepest level of physics, laws are not built from numbers, they are built from symmetry. Symmetry does not mean beauty, it means invariance. It means something stays the same when everything else changes. Shift an experiment from today to tomorrow. The laws don't change. Move it from here to another galaxy. The equations remain identical. Rotate your coordinate system. Physics does not notice. That quiet indifference to where, when, or how you look is not cosmetic. It is structural. And in 1918, Emmy Noether proved something extraordinary. Every symmetry in nature produces a conservation law. Not metaphorically. Exactly. If the laws of physics are the same over time, energy is conserved. If they are the same in every location, momentum is conserved. If they are the same under rotation, angular momentum is conserved. Conservation laws are not add-ons. They are consequences of symmetry. Energy does not persist because the universe prefers balance. It persists because the equations do not care what time it is. This flips the hierarchy. We tend to think of conservation laws as fundamental and symmetry as aesthetic. In reality, symmetry comes first. The laws fall out of it. Mathematics is not decorating physics, it is expressing invariance. And invariance is what makes prediction possible. When we write an equation, we are not capturing every detail of the universe. We are identifying what refuses to change. That is why mathematics works so well. It doesn't try to describe everything. It isolates what cannot vary. The deeper we look, the more physical law reduces to symmetry groups, transformations, and invariance. Particles are defined by how they transform. Forces emerge from symmetry requirements. Even modern quantum field theory is built from demanding that equations remain invariant under specific transformations. Reality seems less like a collection of objects and more like a structure of allowed transformations, and mathematics is the only language precise enough to encode those invariances without ambiguity. This raises a sharper question. If the universe is structured by symmetry, and symmetry is a mathematical property, then is mathematics merely describing the rules? Or is it identical to them? Because once law reduces to invariance, and invariance reduces to mathematical structure, the boundary between math and reality starts to dissolve. Symmetry explains structure, but it does not explain the numbers. The equations of physics are elegant, compact, in some cases inevitable. But inside those equations sit constants, and the constants do not explain themselves. The speed of light, the gravitational constant, Planck's constant, the charge of the electron, the strengths of the fundamental forces, these are not derived from symmetry alone. They are inserted, measured, not predicted. Change them slightly, and reality shifts dramatically. If the electromagnetic force were stronger, stars would burn too fast. If it were weaker, complex chemistry might never stabilize. If gravity was slightly different, galaxies might never form, or collapse too quickly to allow structure. These are not poetic statements. They come from modeling stellar evolution, nuclear binding, cosmological expansion. The equations are precise, but the values inside them appear contingent. This is where mathematics becomes unsettling, because the laws look inevitable, but the constants look selected. Why these numbers? Why not others? There are only three logical possibilities. First, they could not have been otherwise. there exists a deeper mathematical structure that fixes them uniquely. We simply have not discovered it yet. Second, they vary across a larger cosmic landscape, different regions, different constants, and we observe this set because only this set allows observers. Third, they are brute facts, no deeper explanation, just numbers reality happens to use. None of these answers are comfortable. The first demands a deeper, hidden layer of mathematical necessity. The second implies a multiverse beyond direct observation. The third abandons explanation entirely. But here is what matters. The universe does not merely follow mathematics. It follows mathematics with specific numerical settings. It is not just structured, it is calibrated. And calibration raises a sharper version of the original question. If mathematics is the language of reality, then constants are its grammar. So who, or what, fixed the grammar? Or is grammar simply what reality becomes once stability emerges? Because if the laws are mathematical and the constants are not arbitrary, then either mathematics runs deeper than we know, or we are mistaking survivable configurations for inevitability. And that distinction changes everything. At this point, the argument splits in two. Either mathematics is something we created, or it is something we uncovered. If we invented it, then its effectiveness is not mysterious. It works because we shaped it to fit patterns we observe. We refined it, adjusted it, discarded what failed. In this view, mathematics is a compression system, a human-optimized language for describing regularities in nature. Of course it works. We built it from the ground up to match what reality does. But this explanation begins to fracture when mathematics predicts things no one was looking for. No one invented antimatter as a convenient description. It fell out of an equation before experiment demanded it. No one designed the geometry of curved spacetime to fit planetary orbits. Einstein followed mathematical consistency, and the bending of light near stars was confirmed years later. If mathematics were purely invented, why does it keep outrunning observation? The alternative position is older. Plato argued that mathematical objects exist independently of us. Numbers, geometries, structures, not in physical space, but in a realm of logical necessity. In this view, when physicists discover equations, they are not inventing them. They are accessing something timeless. Reality conforms to mathematics because mathematics is not a human language. It is the structure underlying existence itself. This sounds metaphysical, but notice something subtle. Physics already treats mathematical consistency as non-negotiable. If an equation violates symmetry, it is rejected. If it breaks invariance, it is discarded. If it produces contradiction, it cannot describe reality. Mathematical coherence is not optional. It is a gatekeeper. So here is the tension. If math is invented, why does reality refuse to violate it? If math is discovered, where does it exist before we think about it? We are left with an uncomfortable possibility. Perhaps the distinction is false. Perhaps mathematics is neither purely invented nor mystically discovered, but is instead the inevitable structure that emerges whenever a universe allows stable patterns at all. In that case, math is not a tool we use, it is what remains after inconsistency is stripped away. And if that is true, then asking whether mathematics is God's language may be asking the wrong question. The real question might be, is mathematics simply what any coherent reality is forced to look like? There is another way to look at this. Forget beauty. Forget metaphysics. Look at efficiency. The entire motion of planets, the collapse of stars, the behavior of electromagnetic fields can be written in a handful of equations. A few lines of symbols describe processes spanning billions of light years. That is not normal. In any other domain, describing a complex system requires enormous detail. Yet physics compresses reality into shockingly small mathematical statements. Einstein's field equations fit on a shirt. Maxwell's equations fit on a page. The standard model Lagrangian, dense as it is, still reduces the visible universe to structured symbols. This is not decoration, it is compression. Mathematics does not merely describe the universe, it encodes it. Think about what that means. If a short equation can generate an entire class of phenomena, then the universe behaves as though it runs on a compact rule set. That is what compression reveals. Structure. Random data does not compress. Noise resists simplification. The only things that compress well are systems with deep regularity. The fact that physics compresses is evidence that reality is not arbitrary. It has algorithmic depth. The more we understand, the shorter the description becomes. This is why mathematics feels unreasonably effective. It is not that math magically matches reality. It is that reality appears to be highly compressible, and compression only works when patterns are not accidental. Now push this further. If the universe can be encoded in mathematics, then mathematics is not external to it. It is the minimal representation of its structure, not commentary, not translation. Structure itself. Which sharpens the question again. Is mathematics the language we use to talk about reality? Or is it the shortest possible description reality can have? Because if reality is fundamentally compressible, then math is not something we invented to explain the universe. It may be the universe in its most compact form. Now the argument becomes dangerous, because once you admit that reality is mathematically structured and mathematically compressible, you are forced to confront something uncomfortable. The structure appears balanced, not perfectly, not delicately like a glass sculpture, but within narrow ranges. If the strong nuclear force were slightly weaker, atomic nuclei would not hold together. No stable carbon, no complex chemistry. If it were slightly stronger, fusion inside stars would proceed differently. Heavy elements might never form in the same way. If the cosmological constant were significantly larger, space would expand too rapidly for galaxies to assemble. If it were smaller and negative, the universe might have collapsed long ago. These are not theological claims. They are consequences of solving equations under modified parameters. This is what physicists call fine-tuning. And there are only a few logically consistent responses. 1. There exists a deeper mathematical necessity. The constants are not free. They are fixed by a structure we have not yet discovered. The apparent tuning is an illusion of incomplete theory. 2. There are many universes with many parameter sets. We observe this one because only this one permits observers. Selection replaces intention. 3. The constants are brute facts. They could have been otherwise. They simply are what they are. Notice what is missing. None of these options require invoking design. None of them eliminate it either. Physics does not provide comfort here. It provides constraints. The real tension is this. If the universe runs on mathematics, and the mathematics allows many possible parameter spaces, why does our reality occupy this particular region? Is it necessity, selection, or accident? Fine-tuning is not proof of anything, but it removes indifference. It forces you to admit that reality is not just structured, it is numerically specific. And specificity always invites explanation. Because if the constants could have been different, then reality is either inevitable, selected, or contingent. And each possibility changes what mathematics really is. Is it a rigid blueprint, a landscape of options, or a framework that reality happens to satisfy by chance? Whatever the answer, fine-tuning does not weaken mathematics. It intensifies it, because the more precise the calibration, the harder it becomes to dismiss the structure as arbitrary. If mathematics is the operating system of reality, then understanding it is not academic. It is power. Every technological civilization rises by learning to read deeper layers of mathematical structure. Newton turned motion into calculus, and navigation changed the planet. Maxwell turned electricity into equations, and information began to travel without wires. Einstein rewrote gravity, and satellites now correct their clocks using relativistic mathematics just to keep GPS accurate. These are not philosophical victories. They are translations. We do not control reality. We align with its structure. The better the alignment, the more leverage we gain. This reframes mathematics entirely. It is not a human hobby. It is the interface layer between mind and universe. If reality is compressible, and laws are invariant, and constants are specific, then the civilization that decodes those invariants gains predictive authority, not mystical power, predictive precision, and predictive precision scales, energy extraction, quantum computation, gravitational engineering, artificial intelligence, stellar manipulation. Every step forward is a deeper reading of mathematical law. But here is the harder implication. Misread the structure, and reality does not forgive you. Physics does not negotiate. Equations do not bend for belief. If a civilization builds reactors without understanding stability equations, it collapses. If it engineers climate without modeling feedback loops, it destabilizes itself. Mathematics is not optional because invariance is not optional. The universe does not reward opinion. It enforces consistency. So if the cosmos truly runs on mathematical structure, then intelligence is not just the ability to think. It is the ability to decode invariance accurately enough to survive. Which means the question is no longer abstract. It becomes evolutionary. In a mathematically structured universe, civilizations do not rise because they are strong. They rise because they read correctly. And they fall when they don't. We keep calling mathematics a language, but languages describe something outside themselves. Mathematics does something stranger. It does not just describe reality, it constrains it. You cannot build a triangle whose angles do not sum correctly within its geometry. You cannot violate conservation laws without breaking symmetry. You cannot make 2 + 2 = 5. Not because we dislike it, but because consistency collapses. Mathematical structure is not persuasive. It is mandatory, and this is where the metaphor of God's language becomes unstable. If mathematics were merely a language, there would be a speaker behind it. But physics does not require a speaker. It requires coherence. Reality cannot contradict itself and remain stable, and coherence has a form. That form is mathematics. This shifts the entire framing. Perhaps mathematics is not the language reality is written in. Perhaps mathematics is what remains when contradictions are removed. Any universe that contains stable particles, repeatable interactions, and persistent structures must obey invariance. Invariance generates symmetry. Symmetry generates conservation. Conservation generates predictability. Predictability generates structure. That cascade is not theological, it is structural. In that sense, mathematics may not be external to reality at all. It may be identical to the condition that allows reality to exist consistently, which leads to a final turn. If mathematics is not a language, not an invention, not even a discovered realm, but the inevitable shape of any coherent existence, then the question changes. It is no longer, is mathematics God's language? It becomes, could any universe capable of sustaining structure look like anything other than mathematics? And if the answer is no, then mathematics is not sacred. It is unavoidable. We began with a simple disturbance, equations predicting particles before they were seen, symbols anticipating waves before they were measured, abstract structures mapping onto physical law with unsettling precision. At first, it feels mystical, as if reality is whispering through numbers, but step by step, the mystery tightens. Symmetry demands conservation. Invariance generates law. Compression reveals structure. Constants define stability. Fine-tuning narrows possibility. Civilizations rise by decoding patterns and fall by misreading them. Nothing supernatural is required, only coherence. Mathematics does not persuade the universe. It does not negotiate with it. It does not describe it from the outside. It is what remains when contradiction is impossible. Any reality that persists must obey consistency. Any system that sustains structure must exhibit invariance. Any invariance expressible without ambiguity takes mathematical form. So perhaps the question was framed incorrectly from the start. Not, is mathematics the language of God? But, could a stable universe exist without mathematical structure? If the answer is no, then mathematics is not sacred. It is not mystical. It is not even optional. It is the minimal condition for something rather than nothing to remain coherent long enough to be noticed. And that reframes everything. Because once you understand that reality cannot violate mathematical consistency, you stop asking whether the universe is written in math, and start asking something far more consequential. If mathematics is unavoidable, what else is?